Welcome to ChemVid. These videos are to help you understand the basics of chemistry so you can do the activities in class. Please watch these videos and take the notes that go with them. Make sure to watch the videos because I talk about more than what you will just write down on your notes. So it's important you watch them. The video link can be found in the top right corner of your notes, and they are on Canvas. Feel free to re-watch them as many times as you need to in order to really get the concept. All right, let's start with our next topic. Today we'll be talking about separations of mixtures and compounds. So go ahead and take out your notes and let's get started. All right, separations happen in many different forms, so we're going to go over a few of them, but remember there are many more than we'll discuss today. Okay, so as you may recall, we talked about matter and how it was separated into pure substances and mixtures. So mixtures can be separated using physical techniques, and compounds can be separated using chemical techniques. And that's what we're going to talk about, the different ones. So there are two types of mixtures, heterogeneous and homogeneous, and two types of pure substances, compounds and elements. So a physical separation does not change the substance, okay? It's just two things that are mixed together and then you separate those two things. Nothing new is formed, all right? So if you look in the picture, all of the red-green ones are still together. They're still there. They're just separated from the blue-purple ones. All right, mixtures, like I said, can come in many different forms. So gas mixtures, that's when you have two gases mixed together, okay? You can have a liquid mixed into a gas. So when you breathe on your hand and it gets moist, that's because there's saliva mixed in with the air that you breathe out. Okay, so that's liquid mixed in with a gas. Of course, you know solids mixed into liquids. That happens all the time. Sand in water. Whenever you drop a marble in a glass of water. I don't know why you do that, but it's true. So there are many different types of mixtures. So let's talk about how to separate these guys. The first one is filtration. And filtration is based off of size. So if you have something that is a different size, then it gets stuck in the filter and the smaller thing falls through. So for instance, I have a filter in here, and the sand gets caught in the filter. It can't go through, but the water was small enough that it could pass through. All right? You may have heard about that, like spaghetti. When you put spaghetti in a colander, the spaghetti gets caught because it's too big to fit through the holes. We call that filtration, okay? So anything that is separated based on size is filtration. The next one is distillation. And distillation separates things based on their boiling points, okay? So this is another physical separation. And basically what you do is you have a mixture in here over the flame, and I like to use the example of alcohol and water. If you were to mix alcohol and water, alcohol boils faster than water does. So the alcohol heats up, it travels up the tube, and then down this other tube, and then as you can see here, this light blue, that's it has water flowing through it, so it cools the tube down, which therefore cools the alcohol down, and then the alcohol drops into this container. So when I'm done, I will have alcohol over here in this small container, and water left over in this big container. Okay? It can work with anything that has different boiling points. All right, next one. Crystallization. Crystallization is another physical property because it deals with freezing points. Now you know that things freeze at different times. So what I like to talk about is, again, alcohol and water. They have different melting points and freezing points. So if you have alcohol and water in this first flask, if you lower the temperature, the water will freeze first and create these crystals, And then the crystals are big enough to get caught in a filter, and you're able to separate out the alcohol and water. So very similar to distillation, it's just freezing instead of boiling. Another way to see this is if you ever go outside in the winter in the early morning to a chain link fence, you might see crystals on the chain link fence, and that's because the water that was in the air, that was mixed in the air, has now frozen out of the air and attached to the metal, and therefore you are separating them because water is going to freeze out onto the metal where the air doesn't. All right, and this is how they make lollipops and a whole lot of candies. It's very useful. Our next separation technique is similar to crystallization. It's called recrystallization. For recrystallization, what we do is if you ever put salt in water and then boil off all the water, you'll notice that the salt recrystallizes in the pot, okay? And that happens whenever you have any dissolved solid in a liquid that won't evaporate. So the water evaporates, or the solvent, whatever you put it in, will evaporate, but the salt or solid will stay there, and it'll recrystallize into its crystalline shape, like in this picture. So we use this whenever we're trying to get a solid out of water, and one of them evaporates, and the other one doesn't. All right, last one of the physical separation techniques, sublimation. Sublimation is when you go directly from a solid to a gas. And there are many things that go from a solid to a gas. The one that you're probably most familiar with is dry ice. Okay? So if you've ever seen dry ice, it lets off a puffy kind of a smoke thing. That's actually just the dry ice, the carbon dioxide turning back into its gaseous form. So what they use is a cold finger. That's what this little apparatus is called. So what they do is they put the sample in the cold finger down where number 6 is, okay? And then they put water into number 1 and 2 so that this little piece of glass is really cold. And whatever sublimes, whatever goes directly from a solid to a gas, will rise up and touch the end of the cold finger, which is number 5. And therefore you're left with whatever didn't sublime is still at the bottom with a solid. And then once the gas touches the cold finger, the really cold piece of glass, then it recrystallizes around that piece, and you can just take it out and scrape it off, and you have separated them. All right. Next is chemical separations, or are chemical separations. And in this one, as you recall, the connectivity of the atoms does change. All right. So on your notes, it asks you to draw the separation of water, 2 water molecules into hydrogen and oxygen. All right. So in one beaker, we're going to have water, and water looks like this. You have an oxygen attached to a hydrogen, 2 hydrogens. And then, I drew my beaker too small. Oh well, that's okay. Pretend it's in there. So now I have 2 water molecules. So in a chemical separation, these bonds are broken, okay? So what's going to happen is it's going to turn into hydrogen and oxygen gas. So in one beaker, you're going to have little hydrogens floating around. And since there's 4 hydrogens over here, there has to be 4 hydrogens over here. Again, pretend it's in the beaker. And since there are 2 oxygens over here, that means there are 2 oxygens over here. All right, so that is a chemical separation. It's when the bonds break. Now, sometimes the elements will reform and bond to another, and then you get a new compound. But for this one, they separate into hydrogen and oxygen. And the hydrogen will actually bond with one another. So this hydrogen is going to bond with this guy, and this hydrogen is going to bond with this guy. And then these oxygens are actually going to bond together like that. So that is how you separate water into hydrogen gas and oxygen gas. All right, so water breaks apart, and there we have it. Elements. An element is it's a pure substance, and it can't be separated into smaller substances. The only caveat for that is that elements can be separated with nuclear techniques like nuclear fusion, but they cannot be separated by physical or chemical techniques. There are 92 elements that naturally occur on the Earth. The rest of them are man-made, that we've made in the lab through fusion, and we'll learn about fusion in next unit, I believe. Each element has a unique name and a symbol. So like hydrogen is H, copper is Cu, and molybdenum is Mo. Luckily, you'll have lots of time to learn their names and symbols. And then finally, elements can never be separated except for nuclear fission. This is very important because we're going to say that a lot. You know, elements can't be separated, elements can't be separated. They can. It's just with nuclear fission, and we're talking about physical and chemical stuff right now. All right. Every element that we know of is on the periodic table, and they have their own name and symbol. So if I ever ask you if something is an element, you can always look up at the periodic table and you can see if it is an element or not because it has to be there. All right. Now on the periodic table, we have rows and we have columns. Horizontal rows, the ones that go from left to right, those guys are called periods. That's why it's called a periodic table, because these guys are called periods. And then the vertical ones, like from top to bottom, those guys are called groups or families. Okay? And they're called groups or families because they all have similar characteristics, and it makes it wonderful. We'll talk about that later too. All right, now compounds are when you take two or more of those elements and combine them chemically. So a compound is a mixture of elements, but it is a chemical mixture. Okay? Most of matter in the universe exists as compounds. So you never walk around and you don't just find gold sitting on the ground. Okay? Gold is always connected to something else. It's connected to sulfur. It's connected to copper. It's connected to other things in real life. Okay? So usually what you find when you pick up something, it's not going to be just an element. It's going to be a compound or a chemical mixture of elements. And then people use chemical separation in order to separate those chemicals. Okay? Those compounds so that they can get the elements that they want. Table salt is an example, NaCl, sodium chloride. Water is an example, H2O, and there are many, many, many compounds. So the reason why the world has so many, 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 many things is because those 92 elements combine in different ways, and therefore you create lots and lots and lots of compounds, which therefore create lots and lots of things for us. So even though there are only 92 elements, most of the things are made out of compounds, and there are lots and lots and lots of compounds in this lovely world of ours. Okay, that finishes up your homework for tonight. Go ahead and make sure you understand what we went over. We're going to talk about chemical separations next time in class, so we'll finish the rest of our notes in class, and I will see you then.